dilations, they made congruent figures. The word I just said was congruent, which, if you remember, I said basically meant equal in geometry, right? Like if we had a triangle and all we did was moved it, right, we get the same triangle back. It's just somewhere else. If we rotated it, it's the same triangle, just flipped around. If we reflected it, it's the same triangle, just flipped, right? Same side length, same angle, same all of that. But when we do dilations, maybe the think/warm-up is what I should hit first. What happens when your pupils dilate? They get smaller or bigger. That's it, right? You're making a shape smaller or bigger. So you don't make the same congruent shape. You make a similar shape. Similar shapes have the same, not size, but they have the same like properties, like they have the same angles, right? They look the same, they're just bigger or smaller. They're proportional to each other. So a dilation is a transformation that changes the size of the image, but not its general shape. Dilations produce similar figures, what I just said. A dilation has a scale factor. For example, a scale factor of 3. So if I had something and I gave it a scale factor of 3, I'd make all the sides 3 times bigger. Not necessarily the area, but each. And then a scale factor of 1/2 would cut each side in half and make it half as long. A couple real world examples. I had little Russian nesting dolls, and I thought the giraffes were cute. So I was like, I'll put the giraffe there. It is a tiny giraffe. I'm not sure if that's real. Yeah, I know. It's like in like where a building is. You don't think so? I feel like they have to be. I don't know. Let's look up how big baby giraffes are later. Okay, so our first example, we're only going to go through one type of example today. So we have a delta mass assignment, and half of it you could do after today, and maybe you could do the other half too if you work on it. But we're going to go through the first half of the example today. So plot the image of, what was that, OPQR after a dilation with a scale factor 2. One of the sides has been plotted for you. So it does this side for us, R prime, Q prime, RQ, so that we can work from there. And on delta mass, you just make more lines to match it. So a scale factor of 2, we're dilating this. A scale factor of 2 means that we make each side twice as long. So you'll notice we went 1 dot, 2 dots, but here they went 1, 2, 3, 4. Okay? Well, the same thing can happen here from R to O here. So I'm looking at this one here. Notice how far I go down. I go 1, 2, 3 dots down and 1 dot to the right. If I have a scale factor, I can go 1, 2, 3, 4, 5, 6 dots down and 1, 2 dots to the right. I times both of those by 2, right? 1, 2, 3 times 2 is 6 down, and then 1 to the right times 2 is 2 to the right. And if I'm, well, it can be O prime. Okay, and then this one, 1, 2, 3 down, 1, 2, 3, 4 to the right. So I can go 1, 2, 3, 4, 5, 6 down, right? Double it, and 1, 2, 3, 4, 5, 6, 7, 8 to the right. Double that. Right, so I'm taking the triangle here that I make to each point, and I'm doubling how far I go up or down, and doubling how far I go left or right because I have a scale factor of 2. Right, double means times it by 2. And then the last one is just kind of nice because we don't have to do all that counting. You can to make sure it's right. And if I could draw perfect straight lines, that would look pretty good, I think. Luckily, Delta Math can draw nice straight lines for you. So the big trick there, the ones that are straight up and down or left and right are easy, right? Because you can just count the dots. But here you kind of have to count the slope a little bit, right? Like if you go 1, 2, 3 down, now I need to go 6 down. And if I go 1, 2, 3, 4 to the right, then after I go 6 down, I need to go 8 to the right. Okay. Plot the image of the figure QRST after the dilation factor, scale factor 1/3, or with scale factor 1/3. Scale factor 1/3. 1/3 is not really as easy as a half, right? Half just means divide by 2. Well, yeah, right? What did we do with this one? Double means times everything by 2, right? And if we did have a half, timesing by a half means dividing by 2, right? So really what we do is we times each of these side lengths by 1/3. And when you multiply by 1/3, for example, I don't know, if we have 9 times 1/3, really what you're doing is just dividing by 3 when you multiply by 1/3, because 9 is the same thing as 9 divided by 1, right? You can put any whole number just over 1, same number. 9 divided by 1 is 9. Times 1/3, multiply across, 9 times 1 is 9. 1 times 3 is 3. 9 divided by 3 is 3, right? So 9 divided by 3, division by 3, times 1/3, same thing. So we can kind of just divide everything we need by 1/3. So we should get a smaller image, right? If our scale factor is a fraction, we're making it smaller. And it gave us ST. Let's do this nice vertical one right here first. I see that I've gone 1, 2, right? 1, 2, 3 dots down. What's 3 divided by 3? So I went 3 down. And I want a scale factor of 1/3. What's 3 divided by 3, or 3 times 1/3? 1, right? So I only need to go 1 down. Okay, and then this one I go 1, 2, 3, 4, 5, 6. What's 6 divided by 3, or 6 times 1/3? We know 6 divided by 3, 2. Oh, and look, the one that's not like a nice vertical or horizontal, I could just draw straight in. But maybe I'll do it just to make sure that we can if we need to, right? So here we go 1, 2, 3, 4, 5, 6 up, right? I'm kind of like making an invisible triangle to the next point. I'm starting at this point and I go 6 up, and then I go 1, 2, 3 to the left. And if I times both of those by 1/3, I would get 2 and 1. We just did that, right? So that means go 2 up, so bang, bang, and then 1 to the left. And that would land us right back at S there. And again, if I could draw nice, perfect straight lines, that looks like it would match. Okay, one last example. Plot the PQST after a dilation with a scale factor of 3 halves. One of the sides has been plotted for you. Is it getting bigger or smaller? We have a scale factor of 3 halves. Is it getting bigger or smaller? Bigger, why? Without cheating, why is it bigger? 3 halves. And 3 halves, what's special about 3 halves? It's bigger than what? Yes. It's bigger than 1, right? If you have a scale factor, right, a scale factor of 1 means make the same thing. If you have a scale factor of anything bigger than 1, then you're multiplying it by something bigger than 1 or making it bigger. But if you multiply it by something less than 1 or a fraction, you're making it smaller. So 3 halves is bigger than 1, right? It's 1.5. Yes. So bigger than 1, so we're making it bigger. Here's the trick to these ones, right? It's not just 1/2 or 2 or 3 or 1/3. It's 3 halves. And just like the other ones, right, we're going to multiply the sum by that. For example, this one here is 1, 2, 3, 4, 5, 6. Notice this one is 1, 2, 7, 8, 9. So that was 6. And then they got this one to be 9. Well, how'd they get that? If this was 6, and I multiply that by the scale factor, 3 halves, I'm going to make that 3 halves. Now, here's how I like to think. You can do this multiplication outright, right? If you put 6 over 1, then you times by 5. 6 times 3 is divided by 2. 18 divided by 2 is 9, right? If you're trying to do this in your head, times by 3, divide by 2. Or divide by 2 times by 3, right? 6 divided by 2 is 3, times 3 is 9. So we're going to do that for each of the sides. We're going to multiply them by 1/3. So this one, if I go 2 up, right? 2 times 3 halves. 2 times 3 is 6. Divided by 2 is 3. So that means I'm going to go 3 to the right, 1, 2, 3, and 3 up, 1, 2, 3. And then here, now I'm going 1, 2, 3, 4, 5, 6 up, and 1, 2 to the left. So we just did 2. We can do 6 now, which we already did before. 6 divided by 2 is 3, times 3 is 9. Meaning I'm going to go, from this point, I'm going to go 9 up. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then we already did this one, right? 1, 2 to the left is actually going to be 3 to the left. 1, 2, 3. Oh, an easier one. 1, 2, 3, 4. If I go 4 to the left, 4 divided by 2 is 2, times 3 is 6. 1, 2, 3, 4, 5, 6 to the left. And then underneath that last one, because those are all the points, and they should all connect. I was going to say, my lines are pretty good there, and that actually kind of looks like the same shape. It should, right? It looks a little bigger. So that works.